Welcome everybody. This is day 2 of the Western Regional Panel meeting on aquatic and nuisance species. Thank you everybody for attending today, and thank you our speakers to our speakers from yesterday and our speakers for today. It is unfortunate that we're not having an in-person meeting, but the state of the world, we're not able to do so. Hopefully next year we'll be able to all get together again and network on aquatic invasive species issues. This is my favorite meeting of the year, a great group of people. So our topic for today, our session for today is emerging coastal issues and advancements. Chris Ciani with California State Lands Commission and the Western Regional Panel Coastal Committee Chair will be moderating today. Chris, take it away.
Okay, before I let Chris talk, let me just do a couple of the I guess reminders for our participants too, and then we can dive into introductions. So if you do have questions, all the attendees out there, thank you for being here. If you have questions during individual presentations, please put those in the question box, and if you can, address those to the specific speaker to help us guide those questions. All of these webinars this week will be recorded, and then the goal is to get those posted on the Western Regional Panel's YouTube channel. Upcoming in terms of some social activities for this week, on Thursday at 5 p.m. Mountain Time, we will be hosting a fun happy hour via Zoom. You can find that link on the WRP website. Also, for all the attendees, we will be circulating a survey after the meeting to hear what you thought about everything and what you think about for 2022. And then a couple of other just WRP related. If you are currently not on the WRP listserv, which is kind of an information exchange online area, which gets you the monthly e-newsletter, and you want to be on that, just simply email me. I'll put my email in the general chat area. And then also finally related to this week itself, all of the voting members of the Western Regional Panel annually submit member reports. All those have just been compiled and they are available to you, and they've been posted on the website as well. And I will put a link to that in our chat area. So if you want to know what everybody's been up to, which we're missing out on all that chatting in the hallway and whatnot and over beers. So with that, now, Chris Ciani, please help us introduce this session on very important coastal issues. So Chris, go ahead.
Thanks, Leah, and thanks, Tom Wolf. So yeah, today's session is on coastal issues, and as Tom said earlier, my name is Chris Ciani. I'm the program manager for the California State Lands Commission's Marine Invasive Species Program, and I've had the privilege of being the chair of the Coastal Committee for the Western Regional Panel for the past few years, and wanted to quickly, before we jump in, take the opportunity to plug our committee and hopefully recruit a few members. So our coastal committee is made up of a bunch of government agency folk, academics, industry, NGOs, big group of people that are interested in aquatic invasive species issues related to the coastal area. We have a group of about 40 or so, and we're all pretty highly active. We work on a lot of different products that help move our collaboration forward, and we'll be talking a bit about giving a quick update of the Coastal Committee's accomplishments, I guess, over the past year during the business meeting on Friday. So if you're interested, take a look at that. If you're interested in joining the Coastal Committee, you can send an email to coastal@westernregionalpanel.org, and we'll get you added to the list. So with that, we're going to move into the session. Our first speaker is Tom Ford. Tom's the Chief Executive Officer of the Bay Foundation. He's the director of the Santa Monica Bay National Estuary Program, and he's the co-executive director of the Coastal Research Institute at Loyola Marymount University. Today, he's going to talk to us about his work to target a native nuisance species to reverse the trend of kelp deforestation locally here in Southern California. Really interesting work, and I'm looking forward to hearing more about it. So on to you, Tom.
Thank you, Chris. Thank you, Leah. Thank you, everyone. Am I coming through okay?
Looks good. Yep.
And and I think now I'm back on and my presentation is off.
Nope, your presentation is visible to us.
All right, fantastic. Maybe if I turn off my webcam, I can see it too. There we go. Perfect. If I'm still on my first slide here, here's a beautiful shot of the Los Angeles coastline from Will Rogers State Park up near the Pacific Palisades. About centering the frame off to the left, you can see the Santa Monica Pier stretching across the beach and the little bit of white water that the break wall there creates. A little further down, the entranceway from Marina del Rey, that lower level, almost looks like a whale breaching, is the Palos Verdes Peninsula, and then in the distance, in the background, far off to the right, which to me resembles a bit of an alligator from my time in Georgia, is Catalina Island. Chris touched on it in the intro. The Bay Foundation coordinates a lot of local activity and conducts a lot of local active management of our resources in coastal Los Angeles County. We work along our beaches, our wetlands, our rocky reefs, and I will be focusing much on that today. We have some nascent efforts to better understand the extant condition of our offshore eelgrass beds. I may, if I don't run out of time, I'll touch on that as well. So let's jump into it. With Los Angeles, I think our coast is known for a lot of things. The pier, going to the beach, surfing, all of that. I don't think folks often associate coastal Los Angeles County as a biodiversity hotspot. Certainly the Palos Verdes Peninsula shares a continental shelf with the Redondo Submarine Canyon, the San Pedro Escarpment. We've got a lot of upwelling in the area. This used to facilitate dense stands of productive and diverse kelp forests. We know they were there historically. What we've seen shift in the past about 100 years is a decline in the kelp forest over time, being supplanted by persistent urchin barrens. The images on the screen are urchin barren on the left, kelp forest on the right. For those of you familiar, these are often considered alternative stable states in this ecosystem, meaning that subsequent to disturbance, we could go in pretty much either direction, and then either the urchin barren can persist or the kelp forest can persist, and then another disturbance may cause things to flip back and forth. Yet they can be stable on the scale of decades, if not longer, across latitudinal gradients. Come on, slide. Here's a bit of a histogram of data collected on the extent of canopy off of the Palos Verdes Peninsula, going back now about 100 years. We had to make sure that some of those data were pretty solid before we really started hanging our hat on it. But what we can look at, informed by recent surveys, that those 1911, 1945 earlier efforts really did sort of correspond with the maximum known depth occurring for giant kelp, which is that from the bottom all the way to the top algae that forms that three-dimensional structure in that canopy. So it looks like it's actually a very good source of data for us. And over time, about an 80% loss of the kelp forest off of our coast. For those of you familiar with kelp forests, they are inherently very noisy and very dynamic, frequently disturbed habitats, and hence all that jangly up and down that you see. A lot of this being punctuated by El Nino events that certainly do drive a lot of changes in these systems. So just a word about urchin barrens. This is, I think this image pretty much captures it. It's very low in diversity, very low in production. Many desirable ecosystem services that are associated with kelp forests are virtually eliminated when we have these persistent urchin barrens. And really in this image, we've got a few species of fish swimming around, 2 species of sea urchin, some stubbed out coralline algae, and some crustose coralline algae on the rocks, and not much else. So our interest in coastal management said, well, we would prefer having productive, highly diverse kelp forests on these landscapes. That the argument seems to be quite present and easily made that human disturbances, anthropogenic impacts have led to this overabundance of urchins, and therefore the overgrazing and elimination of the kelp forest off of our coast. But when we, so that said, when we were getting this project started, one of the very interesting questions that came out was, well, we knew a lot about kelp forests from years of study, and we have such a wealth of universities and programs that have gathered tremendous amounts of data on kelp forest ecosystems here in Southern California, but nobody studied the barrens. I can understand why. If you're a graduate student coming back with a bunch of zeros on your data sheet, really didn't allow you to play around with stats much. You probably didn't learn too many lessons. These depaupered habitats were very understudied. And as we were advancing through permitting and securing funding for what became a fairly large scale effort, the question came back at us like, well, how do you know that those barrens are so terrible? And we were like, well, of course we do. Everybody does. Went looking through the literature, really couldn't find much information at all. So one of the things that we had to do first off was go out there and get a good current census condition for what these barrens were like versus extant kelp forests on the Palos Verdes Peninsula. We wanted to make sure that we were looking at that throughout various levels throughout the trophic levels in this ecosystem. So here you can see a short list of that. The crustose coralline algae, which is a critical element, something that a lot of the invertebrates recruit to out of the plankton. Certainly if I'm interested in kelp forest and urchin dynamics, I'm looking at urchins, I'm looking at kelps. Then we started identifying some of our remaining predators in the system, being California spiny lobster and sheephead, and kelp bass. So I'm going to quick take you through these slides. Apologies, it'll be pretty quick, but you'll see from the statistics that we were able to generate from this data set that there really wasn't too much of a question as to whether there was a difference or not between these barrens and the kelp forests. So if you look at this graph, this plot, the map of the Palos Verdes Peninsula, anywhere that you see a K in these green to yellowish tones is a place that we were monitoring as a existing site with kelp. All of the Bs point to various spots along the coast that were barren. And we've continued to utilize these sites for comparison of a sort of serial backy design nature to see whether or not our active management of the area has created any changes. We also have a marine protected area that falls right smack dab in the middle of the peninsula, which has leads to some interesting study as well. But certainly profound differences between the barrens. No surprise that the density of urchins was vastly different in the barrens versus the kelp forests. Same with the macroalgae. The direct interaction of these two species is very well established. Oh, sorry, that jumped forward. The red sea urchin, which behaves differently than the purple sea urchins in most cases, and is also the target of the large fishery for this commercial fishery for this species in the state, which played an interesting role in our project to try to restore this area, as there was concern from sea urchin harvesters that our work would impact their ability to conduct their fishery in this region, or that we might have direct negative impacts on the fishery itself. Here's our lobster. Fascinating that after many weeks of swimming surveys in this area, although we had reefs covered with purple urchins, which are a preferential prey species for the California spiny lobster, that we found none of them, absolutely zero, residing in these barrens, because those purple urchins, without access to any real legitimate form of nutrition or calories, because the kelp is just virtually absent from these barrens, that why would you, as a predator of these urchins, spend any time in these areas? They're essentially spiny, empty eggshells. This has been well established in laboratory studies as well as other field work. Come on, slide. Here's our, our sheephead. These guys are pretty good generalists. This is a labrid wrasse. They're quite charismatic. You see them all over the reefs and in other transitional habitats along coastal Southern California. Still significant differences in these fish. And then the kelp bass, which is a prized recreational target for many fisheries with a very well understood life history, became an important species for us to use to try to track the progress of any potential restoration that this project was pointing towards. So really an opportunity to try to actively manage this nuisance species that was suppressing the recovery and spatial and temporal presence of the kelp forests off of the Palos Verdes Peninsula. So I was asked and prompted by Chris to try to focus on the methods, and I'm slowly getting there, but I just know that without giving you folks a bit of the background, it really gets difficult to discuss it. But what I can show you here in this first graph is you see Honeymoon Cove, Underwater Arch, Marguerite, etc. And you can look at the number of acres that we cleared during given years of this project. Overall, a little over 55 acres in the course of those 7 years depicted. Some of my later slides will even have slightly more up-to-date data. And the amount of time we spent underwater and importantly contracting with commercial sea urchin harvesters to be our restoration technicians or engineers, as they like to refer to themselves, over 10,000 hours underwater clearing urchins from these roughly 55 acres that you see. The map on the right zooming in to the various polygons that we have created to track our progress and our movement across these reefs. And then the kelp canopy in brown, 2018 in the spring was a banner year for kelp off of our coast. The bottom forcing was pretty tremendous, and we witnessed more kelp than we've seen in a long time. Sorry, this animation might be a little sticky. No, we got it. So if across the top row, you see pre, and you can look at the sort of colorimetric patterns there. These are the transects that we set up that were nested within a given block, which was nested in a given quad. So our blocks were 10 30-meter by 2-meter transects, and then our quads were 4 of those blocks placed together. Each transect was further subdivided into 3 10-meter by 2-meter segments, and it was on that scale that we tracked the density of urchins on the reefs prior to restoration and post-restoration. So we went from reds and yellows down to blues. The target density for this activity was to get us down to 2 per square meter. We saw individual densities, greater than 50. The target density in this case of 2 per square meter was not an artificial. There were data collected by Wheeler North. Some of you may have had an opportunity to work with him. And he said, look, from all the data I'm collecting over decades down here, Tom, if there's 2 urchins per square meter on the reef after a disturbance, the kelp is able to recruit and or develop from recruits that were senescent on the reef, and the kelp forest comes back. More than 2, things get wobbly, a little over 3, and things often don't come back, and we see this alternative stable state shift away from kelp to the urchins. Oh, pardon. A little touchy with the touchpad. So the actual method that we used to remove urchins from this reef complex was smashing them with geology hammers in these prescribed areas. We would come back within 2 weeks of sending in our restoration teams to check and ensure that they hit on those target densities, again, 2 per square meter, to make sure that we didn't have any pockets left behind. Urchin barrens serve a positive feedback loop to generate more urchin barrens. So we knew that we didn't want to leave any spots behind, and we did not want to be outflanked by urchins that we missed. So it was a very dedicated, very precise effort executed over the course of years. And once we got the urchins down, as you see in this first column of restoration sites noted in blue, those numbers have stayed down. To the right, you can see the comparison to 3 reference sites. So once restoration was ensued thus far, it's shown to be fairly lasting. Other surveys that are conducted in the area are crane surveys. I imagine many of you are familiar with this. It's very similar to PISCO. And in this scenario, what we were able to track through annual surveys on 30-meter transects that are 2 meters wide was the wealth of understory algae or macrocystis and benthic invertebrates, and we can rapidly see an increase in the diversity roughly a year following the restoration work. And then after that, I'd say the noise is fairly typical of kelp forest systems. We also generated some novel MDS plots for this data. I can thank my colleague Jonathan Williams at the Van Tuna Research Group for this. So what we see over time is a convergence in this space of kelp forest restoration sites. The more transparent, the earlier in time. Same thing with the restoration, the more the reference sites, the more transparent, the earlier in this time series progression. And what we see over time is a convergence of all the algae, substory, prostrate, and the canopy forming giant kelp. So we saw some nice convergence in this case across these sites. Same thing occurred for fish biomass. So here's just a quick look at what those data look like as well. Pictures can be worth 1,000 words, and for a lot of folks that we interact with nationally and internationally, this has helped tell the story. This is a site in 2014 prior to restoration. Permitting for this project principally governed by scientific collecting permit from the California Department of Fish and Wildlife, had us take photographs that were, georeference photos where we were trying to get to back to the same exact spot, same exact heading, trying to take a shot in these various sites to track them over time. So prior to restoration, post-restoration in 2017, and post-restoration again in 2018. And my apologies, I don't have a more current copy of these images for you at this time, but we do have them, and we've continued to see a progression. I think you can see a lot of the understory algae building in here, and kelp that has persisted, albeit following usual annual patterns of senescence in the late summer, due to warm water and nutrient stress, and then often removal on local scales due to wave energy associated with winter storms. We've played this video a bunch. I hope it comes across. And it's a lovely testimony to what giant kelp can do. It is adapted to the frequent disturbance which happens on an annual or sometimes sub-annual scale. We can watch our kelp forests come and go in a matter of months. This was us swimming a transect across this section of cove. You saw the urchins prior to removal. Here we are moving to older sites on the same day. So this one was cleared 18 days prior. We see some early successional species of algae already starting to grow. And we'll be moving quite quickly into a plot that is a little over 100 days, and you can see the dense recruitment and development of giant kelp across this reef segment. Generally speaking, this one was a little more rapid than we've seen in some other places, but within 6 months, we would usually see giant kelp reaching back up to the surface and reestablishing canopy presence throughout our restoration sites. Since over this time, we've had the opportunity to work up some of these data and get some publications out to help. I think one of my favorite parts about science is us and our willingness and our need to try to share and learn from one another. There was an interesting corresponding mass mortality event that many of you may be aware of that occurred with sea urchins throughout large expanses of California in 2015 through 2016. That occurrence coincide with a lot of our management work, and regardless of the cause of mortality for the urchins, we saw kelp recruit back. The paper doesn't quite touch on it, but our data from the Bay Foundation versus the data from the Van Tuna Research Group showed that mass wasting event didn't drive us down to that 2 per square meter threshold that we were still using as a target for the project. So once the wasting disease cleared through, we went back out there and continued to drive those urchin numbers back down to where we would have liked. The fishermen have stayed involved in this project. The barrens are of no use to them. They can't harvest out of them. The urchins are often too small and almost without exception have no gonad in them for the production of uni for my sushi plate. So by bringing these fishermen in, making them part of this win, we were employing them to put back the resource that they could then harvest from again in the future. And indeed, that's happened. We modeled expected benefits of upwards of 168% increases in gonad in these remaining red urchins in the areas. That manifested often within about 8 months to a year and a half, basically turning these back into productive fishing grounds. So we saw the kelp forest come back, we've seen the jobs come back, so thus I'm characterizing it as ecological and economic revitalization. This was also, I think, all happening at a time when climate change went from something that folks were talking about in academic circles or theoretically. This is the time frame for this project is preceded by pilot scale studies going back to 2001, and what we saw was that we were dealing with warmer water events, longer, more persistent warm water events or marine heat waves, anticipated increased storminess and wave energy on our coast, and changes in direction and seasonality for that, ocean acidification, and increased erosion from wave run up. So we started working with folks, notably Kristen Elsmore, who is earning her PhD at UC Davis, did a lot of physical measurements and chemical measurements within restored kelp forests. So we started to get a look at how we might be able to alter currents, sediment transport, increase dissolved oxygen levels, increase pH within these kelp forests, and look at them as not just maybe ecological and socioeconomic drivers, but also as places where we may be able to locally mitigate climate change related changes. Climate change related changes. That's very well stated, Tom. Climate change stressors manifesting in our coastal ocean.
Hey, Tom, you have about
yes.
2 minutes left. You have 2 minutes
Perfect.
left. So,
Perfect.
okay.
Thank you. We are not solely driven by our kelp forest work, nor is our public charge grant given us by our 35-member strategic advisory board. So we're looking at soft bottom habitats, and recently have taken a pronounced interest in Zostera pacifica. This is the lesser known congener of Zostera marina, which we have now been mapping with our colleagues at POWA Marine Research Group off of Catalina. And you can find this angiosperm growing in 75 feet of water off of our coast. We see a great potential of trying to reestablish this biogenic substrate to our coastal ocean in Santa Monica Bay as a way to further provide habitat, resources, sequester carbon, improve water quality, et cetera. Notably, some of our other work is also trying to reestablish dune systems along our beach so that we can increase the verticality of our coastline to try to keep up with sea level rise, and thus keep the sediment where we want it and not have it, in this case, tying back directly to the purpose of today's talk, being deposited in excessive amounts on our reefs, burying our reefs or scouring them, and then further negatively impacting the stability of our kelp forest systems. And here's a bunch of the good folks here enjoying the coast of California. And as much as the colors in this picture are so beautiful, they also, as many of you now recognize what these colors imply, that this is, those aren't clouds, that is smoke from our persistent wildfires. This was a few years back when this picture came across, but a reminder of the interconnectivity of these landscapes, and again, a reminder of the folks who I think all of us are charged with trying to serve and provide a better place to live for current and future generations. That is my contact information, and that is the end of my presentation. And I'm happy to take any questions with the time that we've got left.
Well, we do have several questions, but to keep us on track, I'm just going to pose the first one that was brought in here. So Mark Sitzma asks, is there any evidence that non-native algae, for example, Undaria, can invade in areas that are disturbed by urchin grazing, or do native species come back too fast for non-native species to become established?
We certainly keep an eye out for this. Undaria was never a species that we encountered. We did see Sargassum honorei in a couple very small locales recruit in shortly after we cleared the urchins. And it definitely sent up a huge alarm signal that, like, uh-oh, we might be working in a new paradigm. But what we also saw was trailing only about a week behind that, was the development of Macrocystis pyrifera. Once the Macrocystis grew and did outpace the Sargassum, we saw the Sargassum eliminated from the reef. And it's very difficult to find individual honorei on the Palos Verdes Peninsula at this point. If we had asked that question, I think our data could have helped inform that, hey, wow, you know what? Removing an endemic grazer could actually directly or indirectly help you manage invasive alga, but we really weren't set up to inform that question.
Great. Well, thank you so much, Tom, for presenting for us today. We're going to move on to our next speaker, but we really appreciate you sharing your work with us today. So thank you so much. And I'm sorry if we didn't get your questions answered, but if we could come back to things at the end of the session, we will try to do that. So Chris, back to you for our next introduction.
Cool. Yeah, great stuff, Tom. And yeah, if there are additional questions that you haven't asked yet, go ahead and put it in the chat. And if we have time at the end, we'll get back to it. Next, though, we're going to shift over to Chris Potter. He's a senior environmental scientist specialist with the California Department of Fish and Wildlife. Chris covers a wide range of roles and responsibilities for the entire marine region, including but not limited to serving as the mitigation banking coordinator, endangered species coordinator, and most relevant for his talk today, he's the co-chair of the Southern California Caulerpa Action Team. Chris is going to talk with us today about his work to help lead a coordinated rapid response to a caulerpa infestation in Newport Beach here in Southern California. So Chris, you take it away.
Great. Thank you, Chris. So yes, again, I'm Chris Potter. I'm with the Department of Fish and Wildlife with the Marine Region. And yeah, I thank you for this opportunity to present on a rapid response to a caulerpa infestation that was discovered in Newport Harbor. Next slide. So in late March, Caulerpa prolifera, an alga native to Florida and other subtropical areas, was identified by a diver in Newport Bay while doing filming work for the city of Newport Beach. After the initial field identification, definitive identification was done by the California Department of Food and Agriculture's genetics lab. After genetics verification, CDFA contacted my department, the Department of Fish and Wildlife, and the National Marine Fisheries Service, who in turn reached out to other state and federal agency partners. While Caulerpa prolifera is known and it's a known and legal alga in the aquarium trade, the source of this current infestation is unknown. The known infestation is on the west side of the entrance channel, which is, I think we'll see better in the next slide, in an area known locally as China Cove. Initially, it was estimated that there was around 200 square meters of seafloor infested with Caulerpa prolifera, just distributed over approximately 2 acres within China Cove. Next slide. So you can see the entrance channel there that I had mentioned. So lower Newport Bay is that area of the bay located south of the Pacific Coast Highway. The lower bay is dominated by residential and commercial areas with multiple marinas and mooring areas. Upper Newport Bay is located north of the PCH. The extreme southern end of Upper Newport Bay also contains residential and commercial operations, including the Dunes Resort and small marina and mooring areas. And the Upper Newport Bay Ecological Reserve is located just north of the Dunes Resort and the recreational area. Next slide. Caulerpa prolifera, like other Caulerpa species, is known to outcompete native species and thus disrupt ecosystem processes. As shown in the photo here, the alga is bright green. It consists of a number of blades linked by underground runners, stolons, which attach to the substrate with small root-like structures with rhizoids. When it's outside of its native habitat, it's known to exist outside of normal temperature, depth, and other habitat ranges. It's assumed, based on other Caulerpa species, that no native herbivores can consume prolifera. The species spreads primarily by fragmentation, meaning that even a small fragment of the algae or rhizome can become a new plant, However, there is no danger from the species to human health. Next slide. An earlier Caulerpa infestation was discovered in Southern California in 2000, first in Agua Hendiana Lagoon and then later in Huntington Harbor. However, it was a different species of Caulerpa, specifically Caulerpa taxifolia. As you may be aware, Caulerpa taxifolia has had disastrous impacts in the Mediterranean and other locations and can cause extensive ecological and economic damage if not addressed. The Southern California Caulerpa Action Team, or SCAT, was formed to address the Caulerpa taxifolia infestation. The SCAT included experts from local, state, federal agencies, as well as experts from universities and other institutions. The primary agencies involved in the SCAT were my department, the Department of Fish and Wildlife, the National Marine Fisheries Service, San Diego Regional Water Quality Control Board, California Coast Commission, the U.S. Fish and Wildlife Service, and the State Lands Commission. The SCAT response to the taxifolia infestation included an eradication effort followed by years of extensive monitoring before it was declared eradicated by the SCAT in 2006. The multi-agency eradication effort totaled more than $7 million. So in order to prevent new Caulerpa taxifolia infestations from going undetected, the Department of Fish and Wildlife, the National Marine Fisheries Service, and other state and federal agencies now require taxifolia surveys for most development projects in Southern California. Next slide. While prolifera is a different species of Caulerpa, there's enough similarity between taxifolia and prolifera to set off warning bells. Consequently, the Department of Fish and Wildlife and the National Marine Fisheries Service took the initiative to reconvene the SCAT in April of this year. The department is currently co-chairing the effort along with the Santa Ana Regional Water Quality Control Board, and we meet regularly, often more than once a week. The SCAT participation also includes, again, the Fish and Wildlife Service, the Coastal Commission, the City of Newport Beach, in Orange County. The SCAT is led by a steering committee and is assisted by an outreach committee, a technical advisory committee, and a regulatory committee. One of the first orders of business for the SCAT was the development of an eradication plan. At the request of the steering committee, a group of technical experts drafted the plan, and it was approved by the steering committee in May. The plan consists of 3 phases. One, removal of Caulerpa prolifera from the infested area in China Cove. 2, short and long-term monitoring in the infested area. And 3, long-term surveys outside, surveys in areas outside of the infested area. This not only includes other areas in Newport Bay, but areas south of the entrance channel. It's important to note that long-term monitoring means 2 to 3 years, if not longer. The SCAT was very fortunate in securing funds to enable a quick response. Phase 1 is being funded by the State Water Resources Control Board's cleanup and abatement account. This work is being performed by Merkel Associates and its subcontractor, Marine Taxonomic Services. It's important to note that Merkel Associates was instrumental to the eradication of Caulerpa taxifolia in San Diego. Phase 3 is being funded jointly by the U.S. Fish and Wildlife Service and the National Marine Fisheries Service. Part of this work has already taken place actually and was performed by Merkel Associates and Orange County Coastkeeper. Unfortunately, phase 2 is unfunded. The initial budget for the overall effort was $912,000. Again, with funding coming from a variety of state and federal agencies. However, we have an overall funding shortfall of almost $400,000. Next slide. The Department of Fish and Wildlife supplied divers and a vessel to do a full 100% coverage surveys of the areas shown here to inform the permitting agencies on whether Caulerpa taxifolia was present in the Army Corps' dredge footprint for the entrance channel. Fortunately, no Caulerpa taxifolia was identified in the Corps' dredge footprint. The larger map shows the department's dive surveys overlaid on the dredge footprint. I'm happy to note that the Army Corps we were able to coordinate our activities with the Army Corps, and they just wrapped up their dredging operations early last week. Next slide. This is a video that was taken by one of the Department of Fish and Wildlife divers in Newport Harbor, of course. As you can, if you click on it, it's about 45 seconds. As you can see, the Caulerpa is growing in and amongst native eelgrass and is beginning to outcompete it. Is it not running?
Yeah, Chris, I'm playing it, but I think it's telling me I don't have QuickTime, so you must be an Apple user and I must be a
bummer.
Microsoft user.
There are all kinds of.
So, sorry.
Oh,
Sorry.
well, yeah. Anyway.
Shall I advance to the next slide?
Yeah, please go for it. Thank you.
Sorry about that.
No problem. So implementation of the eradication plan began on June 16th this summer with Merkel & Associates performing eradication level surveys within the China Cove infestation area. A total of 48 patches were observed within a total of 1,060 feet of area. Patch size ranged from 0.1 to 926 square feet. The 0.1 size represents a single frond that was discovered. Distribution is similar to what was previously observed in April by Merkel & Associates and by the Department of Fish and Wildlife's divers on April 29th. Interestingly, some of the previously identified unanchored, what we call rollers, were not present where previously noted in April by Merkel & Associates. These could have been transported by currents to other areas of Newport Bay. The two southernmost points are single fronds as well, and were found growing in sediment. Theoretical diver tracks along transects are shown to represent survey intensity and apply to all transects. So you can see how close the diver sweeps are actually, and if you look in the lower, at those lower transect lines. Fake Caulerpa were placed to test to determine effectiveness of surveys. The return rate of fake Caulerpa was 80% for the single frond units and 83% for the 5 frond units. The total team efficacy for this survey effort was 81%. Next slide. Survey efficacy was tested by seeding the survey area with faux Caulerpa fragments that were collected along with real Caulerpa that was encountered. Because the faux Caulerpa distribution was known, it could be used to estimate the likely find rate for real Caulerpa based on the find rate for faux Caulerpa. Again, the range was 78 to 86%, and thus to increase in effectiveness, surveys have included multiple passes at 100% coverage level. Next slide. Merkel & Associates and his subcontractor, Marine Taxonomic Services, led the removal of the Caulerpa from China Cove between July 6th and 14th. Dredging was conducted by, or the removal was conducted by diver-assisted 4-inch suction dredge, pumping the algae and sediment to a primary filter box where the sediment and algae were captured. The box decanted to a second filter box where water was filtered again through a 1 millimeter mesh prior to release back to the bay. You can go to the next slide, please. During dredge removal, divers collected fragments and swept outlying areas to remove smaller occurrences. Each day of removals, the material was collected from the filter boxes shown here on the, shown in these two pictures, and stockpiled in temporarily buried sand piles on the beach for ultimate disposal. At the end of the removal effort, algae, filter fabric, and fine sediment were collected by the city of Newport Beach and taken to a city yard where it was spread to dry and subsequently hauled to a sanitary landfill. A demobilization for the beach was fully completed by July 20th. Next slide. Just had to close the door. So eradication plans have been made. Sorry. So 2-week surveys were completed between July 29th and August 10th. These surveys found 118 fragments, including attached and rollers. The removal area survey was expanded based on finds of 3 outlier patches beyond the pre-treatment boundaries. 4-week surveys were completed between August 11th and August 17th, and these surveys found 121 fragments, including attached and rollers. Much of the material shows evidence of emergence from sand burial, unfortunately. The finds remained largely represented by small fragments, with the overall biomass and fragment size diminishing, but the number of fragments remained high. Recommendations have been made by Merkel & Associates and Marine Taxonomic Services to accelerate the surveys from the eradication plan, which were scheduled for at the 2-week, 4-week, and 8-week and 12-week mark due to the continued high finds of new fragments. Until the number is significantly reduced, waiting for regrowth in order to aid in detection poses a greater risk than the potential spread of loose fragments. While the fragment finds remain high, the overall biomass per survey sweep continues to diminish. The initial removal involved hundreds of kilograms of Caulerpa biomass, while the recent removals amount to less than 1 kilogram total for each sweep. Fragments themselves are being removed are also decreasing in size, with 1 to 3 fronds being the mean size for removed occurrences. As stated previously, as a result of changed conditions found during the removal effort, the SCAT will be developing an addendum to its eradication plan that will address the change in post-removal diver survey frequency and the resultant potential changes in the preliminary budgets identified for all 3 phases of Caulerpa prolifera eradication. Next slide. In conjunction with researchers at UCLA, the SCAT is assessing the potential for using environmental DNA to detect the presence of Caulerpa in the marine environment. On August 15th, UCLA and Marine Taxonomic Services collected water samples at locations near the zone of infection and away from the zone of infection in hopes of getting both a positive and negative hit in the water samples. The samples were stored in a Longmire solution, which will allow us to eliminate the need to find freezer space since this solution can preserve samples at room temperature for up to a year. Again, this is a proof of concept analysis to determine detectability of Caulerpa in a known infected system. The goal is to see if we can detect Caulerpa eDNA or not. Next slide. Confirmation that Caulerpa prolifera has not spread beyond the current known area of infestation is critical for addressing this emerging threat to Southern California's nearshore ecosystem. Should the eDNA work prove viable, then we can imagine using the tool to be a cost-effective way to determine if an infected system is cleared, expand areas surveyed beyond the zone of infection, encompassing any leakage to nearby areas, for example, the open coast. And finally, act as an early detection system, a mechanism for other high-risk areas. Next slide. So funding for the removal phase, as I mentioned, is expected to be inadequate to complete the full 8-week and 12-week post-treatment removals, given the continued high occurrence of small fragments emerging as sand moves through the site. At present, it's expected that full cost to implement removal and immediate post-removal dive surveys will be $412,000, which is approximately a 25% increase over what we requested from the cleanup and abatement count. Additional funding is also needed, as I mentioned before, for the long-term eradication surveys that is projected out to be 2 to 3 years. We're also beginning our outreach to diver shops, aquarium hobbyist shops, and suppliers. And probably the most recent bit of news is that the Department of Fish and Wildlife is today conducting surveys in an area just to the west of China Cove, an area called Pirates Cove, and they've not detected any Caulerpa there. So the last slide. And here's my contact information, as well as my co-chair, Terry Reeder, from the Santa Ana Regional Water Quality Control Board. There's a link here to the Department of Fish and Wildlife's homepage for reporting Caulerpa sightings. And it's not limited to prolifera. We certainly have used it in the past for sightings of taxifolia. So thank you very much.
Thank you, Chris. Perfect. So if we have any questions for Chris, can you put those in the question box, and we will see if we can address those with the time. We do have some time for questions. So Chris, well, I'm going to wait for a question to come in, but you mentioned budget shortfalls numerous times. But so what does that indicate for in terms of like completing work? Are you just sort of prioritizing?
Yeah, you know, it seems that we are, you know, this has been a patchwork of funding for sure, but we've been very fortunate to secure funding just when things were looking bleak. So I'm optimistic that that we'll, you know, be able to continue sort of along the same way. It would have been nice if we could have had just, you know, one funding source to work with, but you know, creativity goes a long way sometimes.
Right. Well, I guess to that end, I do have a question here from Kat D. Rivera. She asks, is there an emergency fund that helps fund removal of any new incursions?
Amazingly, there's really nothing specific for invasives. The angle that we took, I'm sorry, not with state government, but with federal agencies, there definitely is. with the state, we took a water quality threat approach, and that is how we got access to the cleanup and abatement account, which is administered by the state's water quality control agency.
Okay, I have another question from Chris Moffitt. She asks, is there any speculation as to the source?
Well, yeah, we alluded to this a little bit in the beginning. Prolifera is very popular with the aquarium hobbyists, and we've theorized that someone probably had dumped out their aquarium either in a storm drain nearby or right at the beach itself, but we think it's probably from a hobbyist.
Okay. Let's see, another question. Linda Shaw asks how...
And I might just chime in that there's a statute in the California Fish and Game Code that bans the sale of 9 species of Caulerpa, but prolifera is not on that list. And I suspect there'll be an effort, by my department to get prolifera added to that statute.
Okay, let's see. Linda Shaw asks, how would Caulerpa shed DNA for sampling? Curious how that might work for plants.
Well, just through, fragments, and because it's very mobile in the environment. That's part of its mechanism for reproduction. So,
okay. And then I have one last question here from Tom Ford. I believe this is directed to you. I believe so. Okay, so Tom, if this isn't the case, so Tom remembers tarping and in situ chlorination of past efforts in Southern California. Are there any novel approaches to managing or eliminating the species from our local waters?
Yeah. Tom is referring to the in situ chlorination. Are there any novel approaches to? Okay, so the difference between the taxifolia infestation and the prolifera infestation is the aquatic environment is much more dynamic. We have an entrance channel here. The water, they're much quieter waters that we had experienced the first time around, and now we have to contend with significant swells and a pretty good tidal prism. So we were unable, because of that dynamic environment, we were unable to use the chlorination method that we used 20 years ago. The tarps would not stay in place. The chlorine certainly wouldn't remain in place. So we came up with this, this suction dredge approach, and it seems to be pretty effective. However, the fragmentation has been a real concern, and time will tell how truly effective this approach has been.
Okay, well, those are questions here for you, Chris, today. Thank you so much for presenting today. We are going to move on to our next speaker. So back to you, Christiani.
Awesome. Yeah, thank you. Thanks, Chris. That was great. We're going to move on next to Rachel Gregg. She's a senior scientist at EcoAdapt. She collaborates with managers and planners to support decision-making in a changing climate, including communicating climate impacts and response options to diverse audiences. And that's exactly what she's going to talk to us about today. Her talk is titled Integrating, actually, it's different now.
I switched it up, sorry.
A challenging 1-2 punch for management and conservation. So.
Yeah, I decided to make it a little bit more exciting. Sorry, Chris.
No problem. The floor is yours.
Thank you so much for having me. Hi, everyone. I'm Rachel Gregg. I'm a senior scientist at EcoAdapt. My email is down there. But as Chris said, I have been working primarily on climate change, but lately I have been helping to create and start up a network focused on the nexus between invasive species and climate change. So we are starting this new initiative. It's about a year old, but we're slowly building. Our goal is to establish a community of practice, a network to help practitioners, whether they're from the conservation space or coastal managers or food producers, ranchers, whoever you are, integrate climate change science and adaptation with regional invasive species management activities. And we are modeled after the Northeast risk, if you have heard of them before. There are also networks that are being started up in the Pacific Islands, the Southeast, and the North Central region, which is basically Montana, Colorado, and then a little bit further east. So our primary but not exclusive focus is on Washington, Oregon, Idaho, and BC. And we're thinking not only about the ecological impacts of invasives and climate change, but also the additive impacts on ecosystem services ranging from food production to air and water quality and more. So we're doing all of this under the guidance of an advisory team. We have primary financial support from the U.S. Fish and Wildlife Service and the Northwest Climate Adaptation Science Center, and also donated time from the entities that you see here. This is my open invitation to anyone on this call who wants to join our advisory team. Please do so. This is our website, northwestrisk.org. We have a set up Gmail account, and we also have a Twitter account, but we would love to have more people engaged and involved in our efforts because we really do leverage the advisory team for the direction that our network takes. So if you have any suggestions for activities or topics, we'd also be very interested in that as well, and we're going to do our best to create those spaces. So while we don't have specific scientific objectives for the network, we do build off of those of the Northwest Climate Adaptation Science Center. So our goals are really to think about how can we enable practitioners to achieve these objectives. So determining changes in the rate and spread of invasives in various terrestrial and aquatic habitats, figuring out how effective current management actions are under projected future climate conditions, trying to evaluate the trade-offs and benefits of different management strategies so that we're thinking not only about what is ecologically the most important, but also what is financially appropriate, what's going to be effective, and what is also going to be equitable or socially acceptable. And then also determining the potential climate change effects on disease, incorporating disease into this definition of invasive species as well. So related to aquatic invasives, there's really limited data on the current distribution of aquatic invasive species in the Northwest, including information related to habitat requirements, particularly the climate-related variables of those habitat requirements, and also dispersal potential. So one of the first activities we did as the network was this baseline survey to try and understand more from regional practitioners about their priority needs and knowledge gaps. So we adapted this survey for the Northwest from others that were released by the Northeast and the Pacific Island risks to gather feedback from regional practitioners on the degree to which they're thinking about the nexus, emerging practices and policies, and also needs, opportunities, and limitations. So you can learn more about the survey results by visiting northwestrisk.org, and I'm just going to share a couple of highlights here today. So the majority of our participants represented federal, state or provincial or local or government agencies. We had over 300 respondents in about a 2-month open survey. Most work in project or program management or as on-the-ground operators. So those are frequently natural resource managers, maybe a refuge manager, land steward, or a field tech. Many represent organizations focused on species and habitat conservation, about 38% of our respondents, or natural resources management, that was about 26% of our respondents. And the majority operate in Washington, Oregon, and Idaho. The most common management priorities noted by all respondents are biodiversity, rare species and habitats, habitat connectivity, and freshwater resources, whereas the least common were things like agriculture, human health, marine resources, infrastructure, and transportation. Although, as you can see from the respondent base, if we had a bit more of a diversified pool, these would obviously shift. We asked people to reflect on the time they currently spend managing invasive species, as well as their success rate. So on average, respondents currently spend more time addressing existing invasives than potential new invasive species. And about 49% believe that they're currently holding ground against invasion. The majority of respondents indicate that they or their organizations are very or somewhat concerned about the effects of climate change on invasive species management. And about 73% indicate that their organizations integrate climate change at least some of the time. Invasive species of concern that were most frequently mentioned as challenges both currently and within the next 10 to 20 years include zebra mussels, reed canary grass, knotweeds, and Scotch broom. Although you can see a bit more of the aquatic invasive species on the future threats, things that are becoming more of a concern. The highest priorities for climate-informed invasive species management include things like native community resilience and environmental degradation of air, soil, and water quality. And there were less of a priority on things like sleeper species, biocontrol efficacy, agricultural production, and economic impacts. But again, those sectors are, or at least the economic and agricultural production, they're less represented in the survey responses. So we would like to do an update to the survey to really diversify the respondent pool, but this was a good baseline start for us. And one of the most important things we wanted to ask people was what limits their ability to take action, both with and without climate change as a factor. So limitations that consistently affect people's ability to successfully manage invasive species include things like staff capacity, funding, and other management priorities, both with and without climate change. Those are consistent across the board. But factors that become more of a challenge with climate change include things like technical expertise. So actually having in-house staff capacity or know-how about what to do to better respond to climate change, as well as the availability of and/or access to information, models, and data. So one thing that people frequently mention to us is, there may be a bunch of data out there that could inform our ability to do management, but we quite frankly can't afford the journal article fees. So how do we even get access to some of this data that's out there unless somebody downloads it and sends it to us in a PDF? So we're hoping that that's one of the gaps that we may be able to fill as well, as providing access to those resources. We also ask people what information and resources they typically use to inform both their invasive management practices as well as their ability to integrate climate change. And far and away, most people rely on best practices and lessons learned and knowledge from their peers to make decisions. We also asked about the information desired, and there's always a desire to learn more from case studies, from workshops and webinars, and also peer-to-peer knowledge exchange. So one of the things that we've been using that survey for is to figure out what are our next steps as a network. And so every day, really, there's some new report about how rapid climate change is challenging all of our abilities, especially decision makers' abilities to adequately pursue their objectives in light of a changing climate. And so addressing climate change can be a really overwhelming ask of people who are already trying to keep up with their current priorities and problems. But climate change is an urgent issue that requires an investment of time and energy and a deliberate approach to really challenge and traditional ways of thinking and have a bit of a mental and emotional paradigm shift in the ways of thinking and doing. So are you going to continue with business as usual, and can you afford to? And where are you going to invest your time and money in your efforts over the long term? So whatever you're doing in terms of invasive species management now, is that going to be viable over the long term? So climate adaptation, I'm sure most of you are familiar with it, but climate adaptation is a very good framework through which to kind of grapple with these questions, because It refers to efforts to avoid, minimize, or recover from the changes we're currently experiencing or expected to experience as a result of climate change. And it can be really overwhelming, but it is a bit more manageable than most people expect. So I've modified this pie chart from a colleague of ours here, but when you go through an adaptation planning process, you may actually realize that you're going to spend less time on those new or completely different approaches than you expected. Instead, you're likely still going to pursue some current activities. So maybe about 45% are going to be those current or same actions that are now more important than ever. And about 50%, maybe you'll make some modifications to your current actions. So maybe you're going to plant in a different area or at a different time of year, or you're going to make sure that there are fuel breaks around wherever it is you're planting. And then maybe 10% are those new or different, completely novel actions that you haven't pursued before and you don't completely have a strategy for just yet. But regardless of what you decide to do, really what we're asking people to consider is you're managing for some desired condition, which is always going to depend on your values and your risk tolerance as decision makers. So the range of adaptation options available to restoration and conservation practitioners and all practitioners really just exist along this continuum, wherein you can decide to opt for managing for ecosystem persistence, where your system is going to be recognizable as the same system, or you're managing for some future state where maybe it has changed or it has fundamentally changed in some way. It's going to be completely different. And so where a practitioner's choices land on this continuum from managing for persistence to managing for change is frequently determined by those management values, your management culture, your risk tolerance, and also your regulatory restrictions. So if you look at a couple of these different approaches, many of you may be familiar with these, but there's resistance, which is where you're going to try and maintain relatively unchanged conditions. You're going to try and, it's your Department of Homeland Security approach, right? You're going to put a wall up, a seawall or a moat around the things that you most care about. So you're going to try and limit the effects of climate change on your resource or resources of concern. In the middle there is resilience, where you're going to allow some change. Maybe your forest changes from a forest to a little bit of a mix of forest and shrubland, but you're trying to encourage a return to some prior condition by withstanding or recovering from the effects of climate change. So you can think of a willow that kind of bends in the wind, but then comes back into some shape. And then transition, that's where your ecosystem has fundamentally changed, where you're intentionally accommodating a shift or a transition to a new state or condition. So that's where your forest or whatever system you're working with has maybe looks completely different from what it used to look like. Another variation of this framework or way of thinking is the RAD framework. So if we're still using our same continuum of managing for persistence versus managing for change, this is where you talk about transformation, ecological transformation, but really it's also about social and economic transformation as well. It's rethinking the ways in which you make decisions on the landscape. So the R in RAD is for resist transformation. Similar to the previous slide, that's where resistance and resilience really fits in. But accept and direct are a little bit different. Or direct is a bit more towards transition, where you're guiding change through an active transformation of your system. But accepting transformation is sort of in the middle, where you're kind of allowing change to happen without direct intervention. So it's really important to note here that restraint is an option, where you're intentionally taking a no action approach. You're observing ecosystem shifts. You're not trying to manipulate outcomes. And the important thing to note about this framework, as well as the resistance, resilience, transition, and then other frameworks that are very similar to this, is that no matter what, you can and should pursue more than one approach at any given time. That kind of portfolio approach to work, especially in light of a changing climate when not all projections are completely associated with 100% certainty, as I'm sure we all know, that can really help you hedge your bets in light of uncertainty in terms of both how the climate may change, but also based on the availability of funding you may have in any given year, week to week, month to month, depending on where you're working. Also, the level of resources you have at your disposal, the technical expertise that was mentioned earlier in the survey, and things like public support. And where you decide to make your investments may shift over time. So if you think back to that pie chart, you may in the near term invest the majority of your efforts in kind of these, business as usual, maybe with slight modifications, that kind of resistance and resilience approaches. But in 20 to 50 years, those percentages may drop as you pursue other strategies to actually direct transformation to something else. So last week, we just hosted our first ever virtual symposium. We split it into 2 days, and we did use the RAD framework to help us structure the talks and invite speakers to come and present. So the first day, we really focused on the state of the science. We had a state of practice panel that incorporated several of the invasive species council representatives, many of whom are on this call. Thank you so much again for participating in that panel, to just reflect on what is it that invasive species councils are thinking of in terms of climate change and invasives, what are current pressures, future pressures. And then we also had a couple of managers come and just give their initial perspectives on climate change and invasives. And then day 2, we provided more of an in-depth introduction to the RAD framework. And then we had presentations and case studies from individuals from both within the Northwest and then also beyond the Northwest that gave really good examples to help inspire some of this change on both resisting transformation, so people who are working on integrating climate change, but working on invasive species prevention and restoration measures, and then people who are working more on the accepting and directing transformation of those new or novel ecosystems. So a couple of the talks that I think may be of particular interest to people on this call, we had Chris Harley from the University of British Columbia give a presentation about the impact on non-native marine species versus the impact on native species during the most recent heat dome event. It's a very good talk. He gives a great audio visual clip of what these mussels sound like now. Jennifer Gervais gave a really good presentation on a synthesis project that they worked on that really dives into what are some of the expansions that we're seeing, what we're not seeing, what the understanding is as far as projections of potential invasives moving into the area. And then also a little bit of, what is an invasive species in light of rain shifts? It's a little bit hard to determine. Again, that sort of goes back to not just impacts on the environment and surrounding ecology, but also what your management values are. And then day 2, Kat De Rivera gave a great presentation on European green crab. And then we had Frank Rahel gave a really great presentation on fish management and specifically applying the resist, accept, direct framework. So we had over 340 attendees, which was really great. We had many more who registered their interests, and we got some really great presentations from people ranging from more of that kind of state of the science to case study examples of on the ground management. And we actually just were able to upload all of those presentations today onto our website. So that's at northwestrisk.org. Our goal is to also work on a couple of different initiatives. We currently have the survey analysis on our website. You can find that there. We're going to start working on some case study examples of this invasive and climate connection, and potentially still using the RAD framework to help us identify which buckets some of these case studies occur in. And then, like I said, one of the biggest issues for people is that they don't really necessarily have a ton of access to or time to read several scientific studies on the connection between climate and invasive. So trying to figure out ways we can help fill those gaps. Is that providing summaries of those scientific studies? Is that providing webinars with those study authors to help them kind of do an office hour type of approach for practitioners? And then hopefully another version of our survey where we can diversify our pool. And our symposium went really well. People seem to really like it a lot. We hope that you enjoy the videos that are there too. And we'd be very interested in anyone who wants to share case studies or webinar ideas. We are more than happy to help host any of those items or partner in any way. So I'd just like to conclude by saying thank you so much. And we want to really encourage you to join the network. So sign up at our website, or you can contact me at rachel@ecoadapt.org.
Great, thank you, Rachel. Excellent. If you have any questions for Rachel, let's go ahead and put those in the question box there. Oops, let me. Okay. So let me just see here. Give me a second to scan for any chats. Okay, I'm not seeing any questions for you directly, Rachel. We'll give it another second here. I guess I could ask you a question. You didn't talk very much about, I guess, your institution, the EcoAdapt. I guess I just wondered the nexus with the, you know, the new kind of stakeholder group that you've created. How does that, you know, function with your current, the EcoAdapt organization that you're part of?
Sure. So EcoAdapt is a nonprofit organization. We're based in the Seattle region. Thanks for reminding me. I probably should have done that at the beginning.
Okay.
I'm so focused on amping up all of our network partners because they've really donated all of their time. But yeah, we focus exclusively on climate change adaptation, and so we were approached by the Fish and Wildlife Service, who is interested in trying to recreate this. What was occurring in the Northeast, because a lot of the work that we do is around facilitating adaptation. We do a lot of adaptation training and a lot of case study work. So trying to document how people are thinking about climate change. We do that through interviews and surveys. So it's a pretty natural fit for some of the items that Fish and Wildlife Service was interested in. So yeah, if you're interested in EcoAdapt, you can visit ecoadapt.org. We also publish a lot of the case studies from this and other projects on the Climate Adaptation Knowledge Exchange, which is our website that we run. So there's a lot of case studies on there. We're hoping to amplify some of the projects that you all are working on. So if you have anything to share, any resources to share, we would definitely appreciate it.
I do not see any. Oh, wait, hold on a second. Okay, yep, Kat D. Rivera has a question for you. So what were some of the biggest take homes for you for the intersection of climate change and invasions from the conference?
Kat, we're supposed to talk about that next month on our advisory team call. No, I think people are pretty clear about what the, you know, everyone who was on our call who was on our conference was already bought into the fact that climate change is real, which is always a great start. Not that doesn't happen in every workshop I go to. And I think a lot less about the intersections, but more about where the gaps are. I feel like climate change is an umbrella issue through which to view invasive species management and the ways in which to improve what we're doing. I think is really important. And I did realize, I think the terms people use, the vernacular is going to be an issue as we try and move forward with a network where people who are very focused on the ecology of systems versus people who are focused more on the services provided by these systems. It will be an important distinction to make sure people don't feel like they're left out of the conversation because we're talking about a particular species. So I think that climate change is the umbrella issue is probably the biggest, being successful as an umbrella issue, I think is probably the biggest outcome of that, which we sort of knew, but it was a good verifier as well.
Great, thanks, Rachel. Okay, so I don't see any new questions for you. So thank you so much for presenting, and then I'm going to hand it back to Chris to introduce our last speaker. So thanks for joining us, Rachel.
Yeah, thanks, Rachel. Mentioning to Leah that within our coastal committee meetings, there's often some good discussion, at least at the surface level, of impacts from climate change and how it impacts how we manage invasive species. And just, I'm sure there's going to be a lot of interest from our group, at least from the presentation we just heard. So hopefully a lot of connections are made today. Okay, next we have Amanda Newsom. Amanda is the Ballast Water Program Data Manager for the Washington Department of Fish and Wildlife Aquatic Invasive Species Unit. She earned her PhD in 2011 from the University of California at Davis, and in 2012 was a California Sea Grant Policy Fellow with our program at the State Lands Commission. So I've been fortunate to spend a year working with Amanda. Great time. I'm really excited to hear what she has to say here on her work in Washington and her perspective on ballast water treatment technology as an option for managing the risk of introducing non-indigenous species from ballast water. So take it away, Amanda.
All right, thanks, Chris. Is my screen coming through okay?
Perfect.
Great. Okay, so as Chris said, my name is Amanda. I'm the data manager for the WDFW Ballast Water Program. We're part of the larger AIS Aquatic Invasive Species Unit in the Washington Department of Fish and Wildlife. We are a small program, 2 inspectors, myself, 1 data entry staffer, and our program coordinator, Alan Ployce, who's the coordinator for the entire unit. Our program works with large vessels like this one pictured at the grain elevator in Tacoma, which is on the south end of Puget Sound, to ensure that they are managing their vessels to prevent the release of marine invasive species. And what I'll be giving today is an overview of how the merchant fleet we regulate is changing as they adopt onboard ballast water treatment technologies. And this is in response to requirements from the International Maritime Organization and now from the US Coast Guard. There we go. So just a few slides to help orient everyone to the scale and the history of the current technology shift. While our program is small, the scale of the industry that we help to regulate is global. Shipping routes connect the world, and particularly here in Washington, up on the upper right hand of this map, we are connected via this network of common vessel traffic routes to ports in the Northwest Pacific, particularly those in Japan, Korea, China, and the Nakodka Peninsula of Russia. We're connected to Hawaii, and in the East Pacific to ports in Alaska, Oregon, California, and Central and South America. All of these green lines represent thousands of vessels transiting every year along common routes, and all of them can carry marine non-indigenous species in their ballast water tanks, which they use for stability, as well as on their hull surfaces. Ballast water, which is what we deal with most, is water used by vessels to control their buoyancy. This bulk carrier, seen as an end-on cross section here on the top left, is discharging cargo, say at a port in South Korea. As the vessel discharges cargo, it begins to rise in the water, which is an unstable condition. So the vessel, while it discharges cargo, takes on water at the port to weigh it back down and keep it stable for its return trip across the Pacific. The problem is that with the ballast water, the vessel has taken on all these little red dots, which represent small organisms or propagules entrained in the ballast lines and now held in the ballast tanks, potentially reproducing and making a nice happy little population. When the vessel reaches port then here in Washington State again, and is going to take on cargo for another voyage, it lets off ballast water so that the cargo won't weigh it down too deep in the water. And with that ballast discharge could come invasive species. These are photographs from a study our program produced with Jeff Cordell's lab at the University of Washington of organisms found in vessel ballast tanks coming into Washington State. They included holoplankton like amphipods and copepods and meroplankton like larval crabs and barnacles. And important to note, Washington State received in excess of 4,000 vessel arrivals in 2020 from these large commercial vessels, and over 5 million metric tons of ballast water was released into waters of the state. Any single discharge event could be the start of another high-impact invasion, with Washington State as the epicenter. The ballast water management paradigm for a long time, therefore, was to reduce the number of coastal species entrained in ballast water. Vessels should conduct a mid-ocean exchange. The procedure for this is that the vessel takes on ballast water at port as usual. then slows down while underway 200 nautical miles from shore, lets off their ballast, and then replaces that nearshore ballast with open ocean water. The expectation being that coastal organisms will not survive in the relative desert of the open ocean, and the ocean water will be far less populous. The truth turned out to be a bit more complicated. This is a key result from the study I mentioned by Cordell's lab back in 2015. The y-axis here is the log density of coastal zooplankton, which is what we're trying to reduce with exchange, and on the x-axis is vessel type. And then the two series are the open diamonds are tanks that had undergone open ocean exchange, and closed squares are tanks that did not. So for the most part, organism loads were lower in exchanged ballast than unexchanged, but not always. Sometimes there was little difference, or even bizarrely the opposite. Now, some of this has to do with vagaries of what samples we were able to get, how many, what our N actually was, how many samples we were actually able to get. But it certainly demonstrates that, across the board, there can be a lot of variation in the efficacy of ballast water exchange. There's another problem with exchange, and that's an operational one. Exchanging ballast while in transit can be dangerous. Miscalculation or sudden changes in weather and a loss of stability can lead to this situation where a vessel has listed so far to one side that the vessel is damaged, the cargo is damaged, and crew are in extreme danger. In this case, the vessel Cougar Ice was conducting exchange on her way to Vancouver, British Columbia, likely made an operational or calculation error and began listing to one side so dramatically that all 23 crew had to be evacuated. Fortunately, in this particular incident, there was no loss of life, but a dangerous condition that could have had fatal results. For these reasons, dramatic changes are taking place in how ballast is managed. For the past 2 decades, marine engineering firms have been developing ballast water management systems, or ballast water treatment systems, that can be installed on board vessels. Taking water treatment technologies and fitting them into the tight, often hazardous quarters on board a vessel and into the unique chemical and biological parameters of marine environments has been a big challenge for the last couple of decades. Legal and regulatory bodies have also been part of this development since its inception, and the policy road has been long, it has been winding, and it is in many ways still in flux. And this is because, and this is a very, very quick and very high-level overview of all of the major entities involved here. Ballast water is managed worldwide by a network of authorities, best practices advisories, and laws and regulations. At the global level, the International Maritime Organization sets guidelines for proper management, and countries signatory to these IMO agreements develop their laws in accordance with this advice. Now, the US is not signatory to the relevant IMO agreements on ballast water management, but we do use these guidelines to inform national laws administered by the US EPA and enforced by the US Coast Guard. The US has, for example, adopted federal requirements that include a directive for vessels calling on US ports to transition to onboard ballast water treatment systems in time, and the timelines for this compliance are based on a vessel's build date and their dry dock schedule. Here in Washington State, then, the ballast water program is part of the Washington Department of Fish and Wildlife Aquatic Invasive Species Unit. We help inform state-level regulations and characterize risks that are specific to our state, and help vessels maintain compliance with the policies that result. And this interaction requires the expert knowledge of our inspection team. We have 2 ballast water inspectors. Chief Engineer Gary Urchin is in the upper left with the glasses, reviewing a ship's documentation with a crew member. And Captain Keith Strike is here with a plankton tow net, taking a sample from a ballast water tank. These 2 are constantly working with vessel crews to improve compliance, while also reviewing their performance and providing feedback to our program. The data that I'm going to focus on today are very general results that we've been able to complete, as our data program is quite small. It's me as the data manager and then one data entry staffer. But I will try and show where we are going next with some of our analyses that regarding technology adoption. This is a result from our most recent quarterly report. The percentage of, and where we're concerned with the percentage of vessels or the number of vessels discharging ballast water that used a ballast water management system in each quarter of 2019, 2020, and the first 2 quarters of 2021. As you can see here, the top line with the square data points is the total number of vessels arriving to Washington per quarter. The major dip here in 2020 is a result of work slowdowns and port closures due to COVID. Below this, with the circle data points, are those arriving vessels that discharged ballast water. And usually we ballpark this at, when we're projecting for the next quarter, we ballpark this at around 1/3 of the vessels arriving will actually discharge. And you can see that that holds fairly consistent. It really depends. Sometimes it does depend on how many vessels are actually arriving. Of those discharging arrivals, this last line with the triangle data points are those that utilize those discharging vessels that utilized a ballast water treatment system. This the percentage of discharging vessels using this kind of technology has grown from less than 30% in early 2019 to over 70% at the end of 2020, continuing to grow in the first quarter of 2021, but now seeming to begin a small downturn again. So my first question is whether we are actually seeing a downturn in treatment system use. The US Coast Guard requires that vessels that have these systems installed either use their treatment system or petition for special permission to use only exchange if their system fails. Naturally, with one data point, this really isn't very instructive yet, but it does make us want to keep an eye out. And if this becomes a trend, we want to determine why. Because we want ultimately to know whether these systems are performing as expected while in repeated use under varied conditions. And if they're not, why is that? Our program has been doing some work, for example, to try to track how well prepared crews are to operate these systems and how common system failures are, or at least those we can track. And to do that, in 2017, our inspection and data programs worked together to develop a ballast water treatment system questionnaire, which I've excerpted here just for illustration purposes. This questionnaire is non-regulatory and thus completely voluntary, but we have gotten very helpful responses. Most vessels are perfectly willing to go through this inspection, go through this non-regulatory part of an inspection. We've gotten really helpful responses from crews during inspections where we were able to, where we had time to ask about these. Among other information, we ask about crew training regimens, any system alerts that have been triggered recently, and general operating parameters to determine whether the system was running as it's supposed to be run. This is still very much in process, particularly on the data end, but we anticipate that it's going to form a solid basis to follow up on some of the data that I'm presenting today. We also want to know which technologies are most commonly in use for vessels that come to our state, because different technologies pose different challenges to crews and to regulators. There are currently 44 US Coast Guard type approved ballast water treatment systems on the market, and more are waiting in the wings as alternate management systems. These systems are also legal to use in the United States pending their US type approval. All of these the approved systems utilize filtration and a primary deactivation technology, or what I'm calling a primary deactivation technology for purposes of this presentation. And these technologies might be UV transmittance, injection of biocides, electrolysis that involves hypochlorite, so electrochlorination. Some use cavitation. And all of these primary deactivation technologies have pros and cons. And ballast water treatment is going to be most effective when that primary deactivation technology is matched to a vessel's expected operations. So at the beginning, back in the early 2000s, there were many different technologies being tested. Microwaves and biological agents were among the rare outliers. Over time, 3 technologies have really risen to the top. And it's now looking more like 2 technologies are going to dominate the market for some time. Early on, biocide injection was a really popular model for experimental systems. So this is just some comparative schematics of common, the common treatment progression for sort of the 3 main technology types that appear in those 44 approved systems. Biocide injection was a popular model for some of these experimental systems and is still in use today. After ballast passed through filtration, a sometimes proprietary biocide would be injected into the intake stream. Then ballast was held with the biocide and neutralized when it was ready to be discharged. Another common technology is electrolysis, or more specifically, electrochlorination. Again, after filtration, entrained ballast water is subjected to an electrical current to evolve hypochlorite. Prior to discharge, again, there's a neutralization step, usually using thiosulfate. Finally, some systems utilized UV light to deactivate any organisms remaining in filtered ballast water. All of these technologies have benefits and drawbacks. So the future of ballast water management for regulators is really one of anticipating and responding to changing vessel operations and navigating a whole new set of operational challenges. For vessel owners, the challenge starts as they try to pick the right system for the conditions they expect to encounter. And technology selection is really going to be limited by your ability to anticipate the conditions your vessel may encounter. And while for some vessels, this makes choices very clear, for others with less predictable itineraries, it may represent a significant challenge. So again, at the very general level, all of these systems are similar in some way. But our concern is which of the primary deactivation technologies are actually showing up in Washington State, and what do these patterns mean for our program and how we adapt to change. For this general pie chart, I'm looking at those arrivals to Washington State that have a treatment system installed. I'm calling them equipped arrivals for shorthand. This includes vessels that did discharge as well as vessels that did not. Now, actual usage of the systems is an essential piece of information down the road, but here for this very general result, I'm really concerned with which technologies are showing up here in our waters that might be used, if depending on how what conditions the vessel encounters. So the large slice in pale green, here we can see that the majority of equipped arrivals to Washington had a UV-based system. In blue, just under 30% of these arrivals use an electrolysis-based system. And the 3rd largest segment at 9% of the equipped arrivals were from vessels equipped with biocide injection-based systems. Blowing this graphic up just a little, I just wanted to zoom in so that you can see that some equipped arrivals use a combination of electrolysis and cavitation, so ultrasound, to disrupt cell membranes. And a very small number of arrivals use ozone and deoxygenation. Again, there are many limits to looking at data from this general angle, but what we can say is that what's appearing in Washington is generally following the manufacturing trend. UV electrolysis and biocide injection systems are very common for vessels in Washington State, with UV out in the front as a deactivation technology. This means for our program that we can anticipate some common risks associated with these different technologies. Biocides and evolved chlorine from electrolysis have to be properly neutralized in discharge streams prior to release back into the environment, and their efficacy will be affected by water chemistry. Electrochlorination can't happen in fresh water, for example. Systems have to have a source of salt water. UV light, which is the most common technology we see in Washington also has limitations. We have encountered some situations just this year where a vessel has had to ask for special permission multiple times to use alternative management methods when they take on water in Vancouver, BC, and then want to discharge it in Washington State. Vancouver, BC is a very turbid port due to the silt from the rivers that converge there. And they're using this vessel is using a UV-based system, so the water turbidity makes it so that there is not enough UV transmittance for to actually deactivate what is living in that ballast water. So our program's challenges in the future will be to help vessels anticipate. I apologize for that. My cat is bonking around in the kitchen. Our program's challenges in the future are going to be to help vessels anticipate the needs of their systems and provide information on best practices so that their systems can be used as often as possible. Of course, what I've shown today is the tip of a very new iceberg in terms of data and ways we can visualize this technology adoption. I personally have my eye on comparisons of technologies between ship types and ports of call. I'd like to see if the systems we've anticipated as good fits for certain vessel types and certain voyages are actually being selected for those vessel types and for vessels that typically engage in those types of voyages. All of this is going to depend on which data comparisons will help our program best evaluate the changing risks to Washington State waters. With new technology comes new concerns, and we want to best assist our regulated community in performing their jobs safely, efficiently, and in a way that best protects our waters. There's also a lot going on with coordination between state and federal agencies. Federal and state authorities are working now to establish our new inspection schema and adjusting regulatory language. Our program, for example, is working with the U.S. Coast Guard in particular, establishing our agency's complementary roles in compliance assessment and education when it comes to ballast water treatment systems. And all of those talks are still very much in process. We here in the ballast water program have been field testing that ballast water treatment system inspection addendum that covers our most pressing questions about how systems are operating in situ. And what we're hoping is that it can form a framework also for conversations with other regions, other states. Hopefully we will be able to bring back some results soon regarding how equipped vessel crews are to handle this major change in management paradigms. So this is my contact information. Anyone who is interested in ballast water management and the technologies that are currently available, I always like hearing from people. Thank you very much. And I will open up for questions now if there's time.
Fantastic, Amanda. Thank you so much. I do have a question for you already, which is great. If you have questions for Amanda, just pop those into the chat or question box. So Tom Ford asks, are there any approaches involving deoxygenation of the ballast water?
Yes, there is that technology. There's one system out there now, and I do not recall the name of it, but there is one system currently US type approved that uses deoxygenation as the primary deactivation technology. We don't see it very often in Washington State. It was one of those ones that's like sitting at about 1% of equipped arrivals. It just seems that that technology, yeah, I'm not positive why that technology is not more common than it is. It may have something to do with the power required to run those systems.
Okay, I have another question for you from Linda Shaw. She asks, are you monitoring Washington waters to see any trends in organisms found near treated ballast discharges?
That is a really good question. And right now we do not have an environmental monitoring program. We kind of rely on people we can contract with and people who we can talk to. It is something that is part of our 6-year strategic plan as one of the things that is essential to a complete program. As I said, you know, the ballast water portion of our aquatic invasive species unit is really 4.5 people. So that doesn't include monitoring. However, that's a good question. Actually, I always have this in reserve because people always want to know about environmental monitoring. And this is before ballast water treatment systems were really widely in use, but this is a result again from that Cordell paper that came out of our program's collaboration with University of Washington. The invasive copepod Oethona was found at Cherry Point, where there's a lot of refineries there, a lot of really fast discharge, ballast discharge going on there, and this invasive copepod is showing up, which has the potential to really change the structure of food webs in those regions up in the North Sound. So thank you for asking that. It gave me a chance to pull this one out.
Perfect. Let's see. Oh, yeah, I have one more here for you. Okay, Christiani asks, I know your survey results aren't ready yet, but do you have any ideas, anecdotally or preliminarily, about how frequently these systems malfunction or how often the crew are trained, especially after crew changes?
Yeah, you know, we receive that information so piecemeal. Sometimes it seems that system failures are happening all the time just because of the way that chaotic systems work, and sometimes, oh, they're working great, you know, for a few weeks. And that, again, that's just kind of the nature of this very chaotic system. I do see that, like, for example, with that vessel I mentioned coming from British Columbia, I mean, this is, that wasn't really a system failure. That was an anticipated condition that did not fit the manufacturer parameters for that system. Hopefully, other system failures are actually falling into this category, and we can talk to vessels about best practices. In that case, it would be taking up ballast at a certain point in the tide cycle when silt is going to be, it's going to be less silty, avoiding taking up ballast at night when fewer organisms are going to be in the ballast, get entrained into the ballast water, hopefully, or avoiding taking on ballast at night. I can't remember if I said that the right way around. So it's hard to say, because again, are the system failures that are being reported as failures really failures, or are they predictable conditions? And in that case, that's a matter of crew training. At the very inception of ballast water treatment systems, there were crews they didn't even operate their treatment system if they didn't have to. Before the U.S. Coast Guard started saying, you know, no, if you have it installed, you have to run it on every voyage, vessels were just not running it because it was brand new technology that they hadn't been trained on. Now, with the U.S. Coast Guard requirements, we're really seeing an uptick in crews that are much better acquainted with the new technology and are ready to show our inspectors system readouts and discuss operational parameters in a way that shows us that things are at least improving. So all of that is very qualitative. I really don't have any numbers because, again, it's just, we're really going to need the data from those that addendum to parse some of that question, which failures are really failures and what training is really training, you know.
Great, thank you, Amanda. That's all the questions we have. So that concludes our coastal session today. Thank you so much to all of our speakers. I'm going to hand it over to either Chris, if you have any closing remarks, and I know Dennis, our chair from the WRP, he does have some closing remarks. So thank you so much.
I'll pass. Go ahead, Dennis.
Okay. Well, thanks everybody, and thank you, Chris, for hosting our session today, or moderating our session today, and thank you to our speakers. Another great day of presentations, and so I invite you all to join us again tomorrow. Leah Elwell will kick us off in the morning, and then turn it over to Nate Owens from the state of Utah to go over, to moderate our session on contributed papers. So we'll see you tomorrow at 12 p.m. Pacific, 1 p.m. Mountain. And don't forget, tomorrow evening, we also have Facebook Live happy hour, or I don't know if it's on what platform it's on, but Leah, if you could send out the link. Zoom, sorry, thank you. So we have a Zoom happy hour, so hopefully you'll all join us for that as well. And thanks again for attending, and we'll see you tomorrow. Good afternoon, everyone.